just a language, right? There's nothing to fear. There's nothing to fear. Nothing. Absolutely nothing to fear. Because I am here. Hello, I'm your host, the Cathobrowski. Today we're gonna program. So I am a C++ programmer by trade. I happen to work in the algorithmic trading business, and I'm still working my way through learning some Python because I'm trying to integrate some AI stuff into my algorithms and into my business in general. Without further ado, I think we should get started. Hold up though. Hang on. Let me change this. There we go. This is a casual day. We're doing a casual stream. Casually work our way through Python. I'm going to try out a few tricks. And chat is live on the screen. It's overlaid on here, so if you got something to say, we could all take a look at and agree to disagree on things. All right, I think this is more or less where I left off, using lists as stacks. Let's blow this up a bit. The list method makes it very easy to list as a stack, or the last element added to the first element retrieved last in first out. Let's see, what does this remind me of? It's kind of like a C++ list, isn't it? Or rather a set. Yeah, okay. So a list is basically like a set. Using lists as queues. So you could append and pop left and whatnot. Okay, list comprehensions. These all seem like things that I could look up for a given library. List comprehensions. List comprehensions provide a concise way to create lists. Huh? Common applications are to make new lists where each element is the result of some operations applied to each member of another sequence or iterable, or to create a subsequence of those elements that satisfy a certain condition. For example, assume we want to create a list of squares like this. For x in range 10, squares append x2. So it creates a list of, okay, so you start with a blank list of squares and you append a bunch of squares ranging from 0 to 9. 9 inclusive, so 10 exclusive. Not inclusive, however you phrase that. Yeah. Note that this creates or overwrites a variable named x that still exists after the loop completes. So what? This is a little bit different. This looks like it's a little bit different from C++, where x would have been local. A local variable that ignores the global variable. So does it follow that? I can't remember what variables are local and which are global, but I would assume that variables inside of a function or a method would be local. But once you're outside of that scope, then it's probably global, I'm guessing, based on context. All right. Note that this creates our over... Oh, right. We already said that. We could calculate the list of squares without any side effects using... Okay, now we got lambdas. So what am I looking at? Or equivalently... Oh, two ways to do the same exact thing. Oh, so the reason it's local is because you have a lambda function. Wait. Let's break this down a bit. Hold up. Let's lambda x. How do you do lambdas? Lambda y x 2. Does that work? No, I don't know how this works. I'll have to get to that later. Or equivalently. It's almost like you have to copy paste your way through through Python. So somehow this is a one-liner. Right. A list comprehension. Well, I could always revisit this, right? I still need to learn more of the rules here. A list comprehension consists of brackets containing an expression followed by a for clause. Is it just me or is this a little loud? I'm going to bump this down. All right. Where were we? List comprehension consists of brackets containing an expression followed by a for clause and 0 or more for if clauses. The result would be a new list resulting from evaluating the expression in the context of the for and if clauses which follow it. For example, the list comp combines the elements of two lists if they are not equal. I don't even know what I just read. Hang on a second. XY for X in 1, 2, 3, 4. Huh. And it's equivalent to for X in 1, 2, 3, 4, Y in 1, 3, 1, 4. If X is not Y, append it to combinations. So somehow it's doing the same thing. But they're not equivalent because it's not setting it to combinations. Right. So if I do this, anyways, comms is equal to this. Then I say comms. Then we say F5. Did it do it? Am I blind? Python. flow. Is my environment set up? Hold up. Oh, print combinations. Of course, of course. F5. There it is. Why does it look like this? Another print string format. I gotta get used to this because we just say comms is equal to, and then we say, is it like 1, and then you say comms? Is that how it works? Just going off of memory here. Uh-oh. Oh, does it start with 0? I bet it starts with 0. Righto. F5. There we go. Comms is equal to... There we go. Why does it print before it's even ready to go? That's so weird. What is all this stuff? Anyways. Note how the order of for and if statements is the same in both of these snippets. If the expression is a tuple, for example, in the previous example, it must be parenthesized. Okay. So you create a vector. Wait, a new list called vec for vector. -4, -2, 0, 2, 4. X squared for x in vector. Okay. Filter the list to exclude negative numbers. For x in x if x is greater than or equal to 0, so you get 0, 2, 4. Sure. Apply a function to all elements. Absolute x for x in vector. Yeah. Call a method on each element. So you got a list of fresh fruit, which is banana, loganberry, and passion fruit. Create a list of two tuples like number, comma, square for x, comma, x squared for x in range 6. There you go. So now you got in this little magical one-liner of code, you got tuples with x and then x squared. Sure, sure. That's interesting. The tuple must be parenthesized, otherwise an error is raised. Okay. Moving on. List comprehensions can contain complex expressions and nested functions. From math import pi. String round pi I for I in range 1 to 6. So you'll have one digit all the way to 5 digits. 1, 2, 3, 4, 5. Because it doesn't include the 6. Right? Is it always going to print all the digits though? Hold up. Let's get the REPL going. Whoops. All right, there's my REPL. Here's my question. How much... Oops. Hold up. From math import pi. Okay. Try that again. My question is, how much precision do you get out of these things? Look at this. 793, 793, 793, 793. You're not getting the full 30 digits. Let's count them. 1, 2. Can I blow this up? 1, 2, 3, 4, 5, 6, 7, 8. Looks like 16-ish. So when you convert print, I'm assuming this is what, a 64-bit double, but then I'll just limit the number of digits it'll print out. Surely there's a way to configure. Oh, you know what? There's a string formatting function where we could explicitly set that info, right? I'm guessing that's the case. Alright, so you got nested list comprehensions. Initial expression is in a list comprehension can be arbitrary expression, including another list comprehension. Oh, well, I don't mean to end the stream early, but something just came up. I gotta take care of it. Sorry.